We're going to talk through a couple quick examples of how to find square roots and simplify them. So quick notation is that when we're talking about square roots, we also refer to them as radicals pretty often. So the radical symbol is this symbol. And so we will either call these square roots or we'll call them radicals, just kind of get used to both. So a square root is essentially this. If a squared equals b, then the square root of b equals a. And our reasoning is really here. The square root of b would be the same thing as the square root of a squared, and the square root, the radical, and the square kind of cancel out is how we think about it. So you guys are very familiar with from previous years, but I'll just do 3 quick examples. The square root of 9 is the same thing as the square root of 3 squared, because 3 times 3 is 9. So the square root of 9 is 3. 25 can be rewritten as 5 squared. So the square root of 25 is 5. And 225 is the same thing as 15 squared. So the square root of 225 is 15. So these, you can memorize these if you want or just get used to them, but these are not the hard thing. What we really want to talk about today is what we do when we have square roots that are not perfect. So not perfect square roots are numbers that don't have that clear square root. So for example, over here on the side in green, I've got lots of what we consider to be called perfect squares. And perfect squares are numbers that are, exactly one number times itself. So 1 squared is 1, 2 squared is 4, 3 squared is 9. And so all of these numbers are considered perfect squares. If you're between these, like the number 11, for example, isn't going to be a perfect square because its square root is some decimal between 3 and 4. It's not a perfect number. But we want to be able to take some of these imperfect square roots and write them as like nice clean squares, nice clean answers. So we do this by splitting our imperfect square roots by factoring. So we're going to be taking our questions and factoring our numbers. So I've got 3 examples. The first is, what is the square root of 18? So 18 falls between 16 and 25. And so we know that our square root should be somewhere between 4 squared and 5 squared, 4 and 5. And as we see, if we put it in a calculator, is that the square root of 18 is about 4.24. But we want an exact answer. We don't want a decimal that is approximate. We want something exact. So there are 2 steps to helping us find this. We're going to factor. So what we want to do is find the biggest perfect square factor and rewrite this as a multiplication. So we're going to look at our list of perfect squares and identify which one divides 18 perfectly. And I can see already that 9 is the biggest number that divides 18 that's also a perfect square. So I'm going to rewrite this as the square root of 9 times the square root of 18 divided by 9 is equal to 2. So 9 times 2 equals 18. And then what we want to do is just simplify our 2 parts. So our answer should essentially be a number outside the radical and then a number inside the radical. The square root of 18, as we just said, is the square root of 9 times the square root of 2. And the square root of 9 we know is 3. So I'm going to get 3 times the square root of 2. And if I write this cleanly, it's going to be 3 root 2 is how we say it. 3 root 2. Ooh, and I'm essentially writing it without that multiplication, so it's nice and clean looking, but it means the same thing. So the square root of 18 is just 3 times the square root of 2. That's a relationship we have just proven. So let's take 2 more examples. I think the hardest part of this is figuring out what the perfect squares are that divide. So I would encourage you to have a little list like this somewhere on your paper. I've got it in your slides for the day, so you can reference it when needed. So 275, what divides 275? Well, I want to look through this list and go backwards. Let's start with 275 divided by 49. That is not perfect, as you can see. How about 36? Nope. How about 25? And yes, we get 11. So I'm going to rewrite 275 as the square root of 25 times the square root of 11. And then my answer is just 5 root 11. So I've got to first just identify my two factors. I always want to have just two. Also, I'll get square root of 25 times square root of 11. Over here, we've got root 27. If I look at my list, I should be able to see that the biggest perfect root is 9. So I'll write this as square root of 9 times square root of 3, because 9 times 3 is 27. And then my answer is 3 root 3. All right, guys, good luck. I've got one more video up on Google Classroom for you. It's from YouTube, but if you want to watch that to get another look at this, that might be really helpful. All right, have a good day, guys.